Hello ladies and gentlemen, this is Mr. Cunningham, and what we're going to be doing today is going over notes 13.2, which is over something called solubility. So take a minute, answer the bell work questions for me to the best of your ability, then we'll continue talking about our lesson. Okay, so again today, hopefully you've got your notes page with you. We're going to be going through this notes page over solubility. So on your bell work, I asked you what does it mean for something to be soluble, and how can we give a number to how soluble something is? So we're going to actually be doing that, and I'm going to show you how we do that in our lesson today. But first, let's go over our objectives. So subobjective 1 says we need to be able to define solubility and understand that changing conditions change the solubility of something. Subobjective 2 says we need to be able to define saturated, unsaturated, and supersaturated. So what do those things mean? And then our goal, using a solubility chart, be able to determine if a solution is saturated, unsaturated, or supersaturated. So here we go. So here's what solubility is. So in solubility, what that means is only a limited amount of solute can dissolve in a given amount of solvent at a given set of conditions. So, meaning this, if I had a container of water, I couldn't just endlessly dissolve sugar inside of it. I might add a teaspoon, stir it, it dissolves. Add some more sugar, stir it, it dissolves. Add some more sugar, stir it, it dissolves. Eventually, at some point, that sugar will stop dissolving because it will have reached the point where no more sugar can be dissolved in that water. Okay? So that's what that is saying. Only a limited amount of solute, okay, that's the stuff that gets dissolved, can dissolve in the solvent. That's the stuff that's doing the dissolving. Okay, so each solute, so everything you could ever possibly think of, has a characteristic solubility. All right? Solubility is the maximum amount of solute that will dissolve in a given amount of solvent at a specified temperature. Also pressure. So things that can affect solubility of something is obviously temperature and pressure. Okay? So usually how we express this solubility, at least how we're going to express it today, is in grams of solute per 100 grams of solvent. So in other words, an example of that might be, I have 100 grams of water, how much NaCl can I dissolve in there? That would have a characteristic solubility, okay? So here's what I'm going to kind of expect you to be able to do by the end of the day today, is you're going to have to be able to read one of these charts. So I'm going to give you a question like, you've got this many grams of water, so you've got 100 grams of water, and I dissolve this many grams of NaCl in it. And I would say, is this going to form a saturated, unsaturated, or supersaturated solution? And you'd be able to tell me that. So that might seem kind of like crazy, like, okay, how am I supposed to read this chart? I will show you how to do that after we talk about some of the properties of types of solutions. So the first thing we're going to look at is something called an electrolyte. So an electrolyte solutions are solutions that contain ions and can conduct electricity. So I have two solutions here. I've got one. This one is just sugar in water. And then this one is sodium chloride dissolved in water. Now, hopefully you guys remember this. We actually used this thing earlier in the year. This is called a conductivity tester. So remember, it has these two little prongs. You did this during one of your labs. You put it in the water. If the light bulb lights up, that means it's an electrolyte. So I've got a sugar solution. I've got a sodium chloride solution. And the question is, which one is an electrolyte? Excuse me. So this is my sugar solution. Put these two prongs in the water, and we get nothing. Okay, so what does that mean? Well, that means that sugar does not contain ions, so it can't conduct electricity. Again, and you might say, well, the reason why sugar can't make ions is it's not an ionic compound. Now, NaCl, on the other hand, is an ionic compound. So if it's soluble, it should dissolve, make ions, and conduct electricity. And it does. So this solution, NaCl, is an electrolyte because when it dissolves, it produces ions, and those ions allow electricity to be conducted. Next type of solution, again, is we've got non-electrolyte, electrolyte solutions. Again, we just talked about those. Sucrose is a type of sugar. That in solution, not an electrolyte because it does not conduct electricity. NaCl in solution is an electrolyte because it does conduct electricity. So what we're going to start talking about next is kind of our sub-objective 2, which is what does saturated, unsaturated, and supersaturated mean? So saturated solutions contain the maximum amount of dissolved solute. So an example of a saturated solution would be like, let's go back to our lemonade demonstration, our lemonade idea. Okay, if I'm making lemonade and I want it to be saturated, meaning it can contain as much water as possible or as much sugar as possible, that would mean I dump sugar in, and when the sugar can no longer dissolve, in other words, I dump a little bit more sugar in and I stir it and it never dissolves. That is a saturated solution. It is containing it contains as much solute as it possibly can hold. Okay? An unsaturated solution contains less than it can hold. So most of the solutions that probably you interact with on a daily basis are unsaturated. For instance, if I took, when you're making your tea, okay, if you make tea, you don't saturate your solution with tea, or excuse me, you don't saturate your tea solution with sugar because it'd be like way too sweet. We'd be like diabetic. So we just add a little bit of sugar to make it a little bit sweeter. All right, we don't saturate the solution because it's probably not good for us, right? You might think it tastes better. Actually, in some instances, it might taste worse because you're like, whoa, that is way too sweet. I don't like it. Okay, so unsaturated means I could add more solute and it would still dissolve. Saturated means it has as much solute in the solvent as it can possibly hold. Now, here are some factors that can affect our solubility. Okay, so factors that affect solubility are temperature and even sometimes pressure. So looking at this chart, what it shows is it's got the temperature right here, and it's got the solubility in grams of these particular salts in 100 grams of water. So as I'm looking through this chart, I'm going to follow, let's say something like this line right here. It's kind of orange. I don't know if you guys can tell that, but it's the KClO3 line. Okay, if I follow that line, notice how like right here, it says at 30 degrees Celsius, okay, if I follow this up at 30 degrees Celsius, I can dissolve 10 grams of KClO3 in 100 grams of water. Okay, so all along this line is a representation of where the saturated solution limit is. Okay, so if I just follow this line up, at 10 degrees Celsius, I could dissolve about 5 grams of this compound. At 30 degrees Celsius, I could dissolve about 10 grams. At 70 degrees Celsius, I could dissolve about 30 grams of it. Okay, and those would be forming saturated solutions. All right, so same thing here. So let's say we look at the NaCl line. So it's this blue line, maintains is pretty straight, pretty horizontal. So at 0 degrees Celsius, I can dissolve about maybe 34 grams of NaCl. Then at 90 degrees Celsius, I can dissolve about 40 grams of NaCl. And again, when I'm saying I'm dissolving 40 grams of NaCl, all of these things are for 100 grams of water. Okay, so I'm dissolving this is the amount of each of these substances that can dissolve in 100 grams of water at these temperatures. Okay? So here's a bigger chart of that. Okay? So what I'm going to do is I'm going to talk about what a saturated solution is. Then we'll practice a few on this chart. Okay? So here we go. All right. So a supersaturated solution is a solution that contains more solute than a saturated solution at the same temperature. Here's what it means. It means it's holding more than it should be able to hold. You might be like, how's that possible? Well, here's how you make a supersaturated solution. What you do is you form a saturated solution at a high temperature, and then you let it gradually cool. what happens is that slow cooling allows that substance to stay dissolved. Maybe the best way to think about it, I kind of think about it for like, let's say you're a video gamer, like to play games. So on some video games, like, you know, it's like you can pick up stuff, like you loot stuff around the map all the time. So here's an issue that you have with those types of games is stuff carries weight, right? Like if I pick up a helmet, guess what? It adds weight in my backpack. Well, the problem I always have is this, is I just want to loot and grab everything. So I'm going through a cave and, ooh, something shiny, I pick it up. Well, eventually, as you're going through that cave, your backpack gets full and you're carrying too much. Well, that's a process that's called over-encumbered, and what it typically makes you do on video games is it makes you like move really slow, like you can't run. So it's like you're like inching along. That's kind of like what a supersaturated solution is. You're carrying more than you should be able to carry. All right? So I will show you guys a supersaturated solution. It's actually pretty cool. But let's go back through. So we have 3 solutions that you guys need to be able to identify: saturated, unsaturated, and supersaturated. So, whoops. Here is a chart. You will have this exact chart. You have it on your page. So what I want to do is I want to look at number 1. So it says, what is the solubility of KCl at 80 degrees Celsius? Okay, so all you do is you find KCl. It's right there. So its line is this kind of like purplish, maybe like dark blue line right here. And it says, what is its solubility at 80 degrees Celsius? So all I do is I go to 80 degrees Celsius. It's right here. And I go up to where that KCl line is. So it intersects KCl at about maybe like, here's 50, this line is 50, so it's at maybe like 52 grams. So the solubility of KCl at 80 degrees Celsius is 52 grams of KCl can dissolve in 100 grams of water at 80 degrees Celsius. So let me draw up a scenario for you. If I had 100 grams of water and I put in 52 grams of KCl, stirred it, it would all dissolve. But that would form a saturated solution because I can't add any more KCl, right? Because its solubility limit is 52 grams. If I had only dissolved 50 grams, it would be unsaturated because I could still dissolve a little more. Okay, so here's how you decipher this graph. So in order to determine whether something is saturated, unsaturated, or supersaturated, you find your substance and you go, did I dissolve more than that limit, less than that limit, or at the limit? If it is less than that limit, it's unsaturated. If it is at the line, it is saturated. If it's above the line, it is supersaturated. So here we go. Let's look at number 2. All right, number 2 on your front page. It says, what type of solution is formed when 40 grams of KClO3 is dissolved in 100 grams of water at 90 degrees Celsius? So I need to find my KClO3. Okay, it's this orange line right here. And it said that I dissolved 40 grams at 90 degrees Celsius. So I go to 90 degrees Celsius, I go to 40 grams, and its line is right here. So it intersects right here. Since that is below the line of KClO3, what this line is telling me is I could have dissolved about 47 grams, but I only dissolved 40. That means it is an unsaturated solution because I could dissolve more. Since it's under the line, it would be an unsaturated solution. Number 3 says, what type of solution is formed when 30 grams of K2CR2O7 is dissolved in 100 grams of water at 50 degrees Celsius? So I have 30 grams at 50 degrees Celsius, so I'm looking right here. And it says the substance is K2CR2O7. So at that point, it is right on that line. So here's what that means. That means that at that point, since it's right on the line for K2CR2O7, this would form a saturated solution, okay, because it's right on the line. I have dissolved as much K2CR2O7 in that 100 grams of water as I possibly could, so it's saturated. Here's what I want you guys to do. Take a minute and answer number 4 for me. Try that on your own. All right, So hopefully you got that right. Again, if you have any questions on how to read that, make sure you flag me down and let me know. I'll try to help you guys. So one more thing that we need to cover is the effects of, we talked about temperature, but we haven't talked about pressure. Okay, so we said that typically, even if you look at this graph, what typically happens to how soluble something is as it gets hotter? Notice how, well, let's look at this K or the CaCl2. As the temperature goes up, I can dissolve more of that substance. Almost for every substance, as you increase temperature, it gets more soluble. There are exceptions, however. Look at this cesium sulfate. It actually gets less soluble as it gets warmer, which is really interesting. Most compounds get more soluble as you increase temperature, but not all. The next thing is pressure and solubility. So pressure is affecting gases. So we just got out of our gases unit. For gases, as the pressure increases over the solution, gases will become more soluble in the solution. So here's what I mean by that, okay? I want you to imagine that you have like a piston, okay? And you've got gas up top here. Those are these red particles. And then you've got your substance down here that's a liquid. If I actually increase the pressure, so again, one way to increase pressure is to decrease the volume. So if I decrease the volume here, I'm going to push these gas particles closer together. Well, what that actually forces them to do is it forces them to dissolve in the solution. So as I increase pressure, my solubility as I increase pressure, gases become more soluble in the liquid. Now, what if I did that backwards? What if I had it under high pressure and I relieved it? You know when you see that happen? When you open up a can of soda. Those cans of soda are under pressure. When you pop that top, what do you hear? Tss, right? You hear that release of gas. That's because as soon as you pop that top, that relieves the pressure and it allows gas to undissolve. When that gas undissolves, it rushes out of your container. Okay? It's the same reason also why when you take a can of soda and you shake it up, you agitate it, gases actually become undissolved, and then you open the top and it fizzes over, it goes crazy. Okay? Because as soon as you release that tab, it's under pressure, so the gases quickly want to escape. Okay? You can see that when you open up like a 2-liter for the first time. Usually you see some bubbles rise to the surface. That's because there's gas undissolving. Okay? Alrighty, so that ends our lesson over 13.2, which is over solubility. Go ahead and answer some of those review questions, which are at the bottom of your page, over solubility of temperature and solubility of, or the solubility as you change pressure, just to kind of rehash some of those. Also, answer these questions over reading that solubility chart that we learned how to do today as our goal. Thank you for watching.